Alright, welcome everyone to my YouTube channel. I'm Precious Ugweze. Okay, we'll quickly look at scalar product of vectors, what we also call dot product of vectors. Okay, so if we have two vectors, let u and v be vectors of a particular order, that's a particular dimension. Now, please note that before you take the product of two vectors, whether scalar or even vector product, both of them must be of the same dimension. Okay, so we're assuming that u and v are in Rn. Okay, so if that is true, we are saying that the dot product is defined or given as u dot v. Okay, and to define this, we have two forms of definitions we are going to see, and the first one is geometric form of dot product. And what's the nature of this geometric form? Now this one says that u dot v is simply equal to the magnitude of u times the magnitude of v, then cos theta, where theta is simply the angle between u and v. Okay, so if we have a vector coming from a point, meaning that these two vectors have to be co-initial vectors. You remember what we defined as co-initial vectors. So if there is an angle between these two vectors, theta, so the dot product will just be the magnitude of v, multiplied by the magnitude of u, then cos theta. All right, so that's the first definition. And the second form of definition for dot product is the one we define component wise. Okay, so when we have our vectors in component forms, so since u and v are from Rn, so the implication is that u is equal to u1, u2 up to un, and at the same time our v is equal to v1, v2 up to vn. Okay, so now if we want to define these vectors, the dot product of these vectors, we simply say that u dot v is equal to u1 times v1 plus u2 times v2 up to the number of components they have, that's un dot vn. Okay, and that gives us the component definition for the dot product of two vectors, why this one is the geometric definition. Okay, so we'll quickly look at some examples. Okay, right, so we have these examples here. The first one says we should find the product of the following vectors. Okay, so we're beginning with the first one. All right, and here we can see that all the vectors we are given solution. All the vectors we are given in this example, of course, they are given in component form. We have that u is equal to 3, 2, minus 1, and v is equal to 0, minus 5, minus 12. Okay, so what should we do here? Our dot product is equal to just the product of the corresponding components and the sum of those products. So this is going to be 3 times 0 plus 2 times minus 5, and then plus minus 1 times minus 12. All right, this is going to give us 0, negative 10, and then here we'll have positive 12. Okay, which means that our dot product is simply equal to 2. And of course, we are going to see the properties of dot product. Dot product is actually supposed to give us a scalar. That's why we also call it scalar product. So it's supposed to give us a scalar. All right, that's for A now. And then for B, I will just take B and then you will do the other. So for B, we have that vector A is equal to 5. Okay, so how do we go about this? Say the same thing. A dot B will simply be the component of the corresponding component. Here is 5 and there you have 4. So we'll have 5 times 4 plus 3 times negative 6, and that's going to give us 20 minus 18. Coincidentally, we also have 2 here as our solution. So kindly do the example 3. Find the product of S and T as given here. Alright, and then we'll quickly take another example 2, which says that, okay, so here we have that we should find the value of u dot v, given that u vector is 4I plus 3j, and then our v, the magnitude of v is given, and then there is an angle between the two of them. So if you want to, you may like to draw these vectors, and this is our u. For instance, our u is 4I plus 3j, and our v is given, but what was given actually is the magnitude of v to be the square root of 29, and then an angle was given to be 60, and they're asking us to find the dot product. And like what I said earlier on, all you need to do is to have that u dot v is simply equal to the magnitude of u times the magnitude of v, then cos 60 degrees. So which is going to give us, now we already have the magnitude of v, and we are only looking for the magnitude of u, and the magnitude of u is the square root of 4 squared plus 3 squared, which will give us the square root of 4 squared is 16 plus 9, that's 25, and so this is 5. So if we bring that here, we are going to simply have 5 times root 29, then multiply it by cos 60, and cos 60 is half. So here we have 1 over 2, and this should give us 5 over 2 square root of 29 as our dot product. Okay, and that's all. It's either you are given in component form or geometrically. Alright, so and this is where we'll end it. So take time to do the other example that was left, and find the dot product of S and T. Subscribe to our YouTube channel, and we'll see you in our next video. Bye.